class hash to 11. I'll call it open. Actually, I think is that what the homework assignment was? Hash map open. Open. Make it. Oh, it's a K V. It's just a generic, and you're saying that they don't have to be the same type. That the K, it could be Q and R or any two letters. It's just saying that it's a generic, and that the two types don't have to be the same. Because if you said E and E, you got to store the same type.
Generics have to be capital letters.
I believe so. Yes.
So there's any of the capital letters generics?
I believe so. And then I don't know what you do if you want more than 26 generic types in your class. Well, I do know what you do. Refactor your class. Okay, so we are going to store entries in our array. So we're actually storing the key and the associated value in the array. That's why we have this entry class. It stores the pair. So, generally, what's the first thing we want to do? Find out what the index into the table for this particular key. So find, saw this a lot, yay. That's wonderful. Let's implement it. Oops. So int ret equals key dot hash code. What does that give you? Yeah, it calculates the hash code for this particular instance key. And what? It's an int. What does that mean? Is it what's the value range? Does anyone remember Java and what an int is? It's 2 to the 32 minus, well, 2 to the 31 plus and minus, right? Because ints can be negative. Can I have a negative index into my table? So I want to mod it by length, right? So now I have a value that's, could be negative because that number was negative, but it's between 0 and the length of the table or negative the length of the table. So now I need to say, I could do a potentially math.abs. So now I have a positive number between 0 and the length of the minus 1. So this is a valid index into the table. Now, you could write it this way. You could write it, an if statement, that if the return is, a ret is negative, add the length of the table, and that will get you back into positive space. It doesn't do the same thing as your absolute value, but that's fine. So it doesn't matter. You just want to find a place, and you want to do it consistently and get you into the right place into the table. So I have the index in the table where we think we should put this entry. So let's make an entry. And entry dot key equals key, because I didn't create the constructor. So now I want to check to see if this key and has associated value in it. So let's say right, so I go and find out what's in the array at the index. So, what do I want to do? If there's something there, if there's something there and the keys match, then I want to replace that value. So I'm going to just do it. But we have to take into account something a little bit later. So if test is not equal, null. So there's something there. If test.key equals key. Should I use equals or dot or the equal operator? Dot equals, because I can have a separate key that has the same value. V old equals test dot value. Test dot value equals value. Why are you not happy about that? Talk to me. Weird. And then return old. So we've replaced the value with the new value and returned the old value. Else, so the key didn't match. This is where we do our linear probing. Index equals index plus 1 mod I should do it just to be explicit. And this line is very familiar to you guys. It's how you do the circular queue in an array. You do this a lot in these kinds of data structures. So, and then if the test is not null, there is something there. If the test is null, what do we do? Stick the entry in there. And what do we return? Null, because there was no value associated with the key, because it wasn't. Oops, I'm going to return null. So now, does this work? It doesn't work because if I find something and there's a collision and the keys don't match, I got to increment the index, but I got to go back and check it again. So we need to wrap this whole thing in a while loop. And we want to stop if we've tested every single index in the table. That means it's full, and normally that was where you resize it and rehash everything, but I said you could just return null. So less than table dot length and test is not equal to null. Is that right? But now I need to say here, test equals table subindex. Right. I update the test and increment count. We'll do it right here. Is it? Huh? Is that right? Is that all lined up? No, it's not. And then I need to, if I get out of the while loop, what do I do? What does that mean? If I get all the way through the while loop and it ends, it's not there. The table is full, basically. So that's the linear probing, open addressing. There's another way, instead of just incrementing, we could multiply or add by 4, and there's all sorts of ways to bounce around that table. This is the simplest, but the problem is that if you have collisions, they tend to cluster together because you're just going to go check the next one, which may cause a collision. And when you delete from a hash table, or remove from a hash table, if it's open addressing, you cannot remove that entry, because that indicates that if it's null, you've just broken the chain of collisions to find the item. So you got to put in that fake deleted entry. And that is an issue with open addressing. So this is a reasonable solution to this problem. It's not the only one, but it is a reasonable solution. I think the book has a slightly different one, but any questions?